dot frequency graphs and plots, day one. All right, so we're down right now discussing what the highest and lowest values are because we want our graph to be accurate. Okay, so 10 and 17. So we're going to draw ourselves a number line to start on this. I want to give myself plenty of room here to kind of work with. And then we're going to start at the lowest and finish at the highest. And so now we want to make sure that we get all of our values in. Now in this case, since it's only between 10 and 17, I don't really have to worry about making the values more than one at a time. Well, we can't lose dots. We can't lose data. That would be bad. We're not just going to pick and choose what we want here. Yes, because we want to see how much this actually works. So now, at the beginning you start, and you place a dot above that number for each person. And then what I would personally do is cross that out, so I remembered. Because what if your friend starts talking to you, or something starts going on, and all of a sudden you don't remember, you know, what was happening. And this is what people who crunch data are up to, what they're dealing with. So you can see when, especially, I mean, if you had data working with like thousands or millions of people, well, this gets to be kind of an important job on making sure you do this right, especially when you get into a larger amount of data. So, and we did the other steps as we did it. When we got to a value that already had a dot, we just put another dot above it. It's like making a bar graph almost. And then again, we're evenly spacing everything. We wouldn't want in one chart, you know, to sit here and go dot and then put my second dot up here, and then this one smash them all together. I mean, that'd be kind of silly. If we wanted to make the data look a way we wanted it to, we could do that though. So, now, thank you. Now what we can do is we can use that data to start coming up with some different values, some different statistical data for this particular, you know, bunch of stuff we're looking at. Okay, so our modal score simply means what happens most often. So which age? Right, 15 happened most often. And you can have more than one modal score. Like if I'd have had 3 different values that all had the same number of dots in them, you can have, you know, something that's bimodal, trimodal, it can have more than one. But some other information that we're going to be talking about today and in the future, okay, are some of these terms down at the bottom. So I wanted to get you some definitions of things so you'd have these for future reference. Okay. Range is the difference in my least to greatest value. Okay. So for example, up above, okay, let's see here for a second here. No, yes, no, okay. 1 out of 4, thank you. So the difference in least to greatest value. So like up above, for our example, my range would be 17 minus 10, or 7. So that's how, you know, the youngest to the oldest in this case is what I'd be looking at. Yeah, mean is a way of, another way of saying average. So right, in this case, if we were going to do that, you add up all the values and then divide by the number of values. Okay. So for instance, if I were to be looking for the mean here, let's see if I can pull this down far enough and still get that. It's going to be close. I'll put that back down in a minute for some of you jotting that down. What I would do, just to kind of show you for a minute, and I'll put it back up then, is I would add all of these numbers up. I could even do it off of my my dot plot here. Let's do that. So what I can do, because this is kind of nice when it's organized, I got 3 10s and an 11 and 3 12s. Right now we're actually finding the mean for this one. I got 2 13s, I got 2 14s, I got 4 15s, and I could, if I knew what like 4 times 15 and all that was as I was going, I could make this go a little faster that way. And I got 1 16 and 2 17s. So I add all those up, and then I'm going to divide by the number of numbers. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 dots. So I divide by 18. And most of the time, if you do an average or something like this, you normally round to 1 decimal place, to your 10th place. So if I added all those up, divided, this would be like 13.4 would be my actual mean for this particular example if I was looking at. So the average person was a little over 13 if I was going to measure this out. Median, yep, and there's one more part to that. It's the middle number, the middle value in a list ordered least to greatest. And that's the part that people forget about. They can remember that the median's the number in the middle, but they don't remember, oh, wait a minute, though. It has to be, the list has to be in order. So there's a couple of ways that I'd be able to do this. So if I was doing the median for this one, and actually having the dot plot's going to help me on this, because I can very quickly list my numbers this way. So for every dot you see under a number, I'd have to write that number down that many times. Because once I've done that now to find the value in the middle, to find my median, I'd start at the edges and I would just start working my way in towards the middle. And we'll see if we get to the middle. You're like, uh-oh. Well, now let's see. How are we going to handle this? Because when we get to the middle, there is no one direct middle number, and they're different. So depending on who you talk to, okay, I've seen a couple of places before say that you can go ahead and have both. But the way I'd always been taught, and when I was looking at some of this stuff the other night, the way I kept seeing, normally it's the middle value. If there's 2 values, you're going to find their average. You're going to add them up and divide by 2. So in this case, my median would be 13.5. Okay? The only time we're not going to get a number in the list is if you get 2 numbers in the middle and they're different. If they're the same, I'd just use that number. Okay? So especially if your list is longer, really take your time counting towards the middle to figure out which value that's going to be.
Mr. Hardy, what are the numbers under value?
13 plus 14, because I'm adding these 2 up, and then I'm dividing them by 2. I'm finding their average, or their mean in this case. But if there'd have been just one number in the middle, we'd have just used that for our median. And then mode, because 2 things. 1, there's only one median, and 2, it's usually the middle value in the list, but there's not just...
You could say between 13 and 14 is 13.5.
Yeah, 13.5, because we want to be exact.
No, but you didn't have to like add them together in the one.
He's saying that 13, but like, why don't you just meet like between 13 and 14? Because the answer is 13.5, but it's not always going to be like that, right? Like if it's like 26 and like 27 or 20, like it's not going to end up being right in the middle, right? I only know how it's
Yeah, well, if there's two numbers in the middle, it would be the average of those two numbers, right? Well, if you did it with 26 and 27, you get 26.5.
Exactly. Why can't you do that?
Yeah, that's right in the middle. You don't have to physically write that out if that's what you're asking me.
Yeah, that's what I mean.
Yeah, if you could just look at it and know that it's the number in the middle, that's okay. Yeah, I just like showing people just in case they're not sure where my number's coming from. Uh-huh. It is. The mode is the number that occurs most often. So what would be our mode in this particular one? 15. This number shows up most often. So our main focus here over this next unit is going to be taking the information that we get and actually being able to find values. And we'll kind of keep expanding this, but these are the 4 basic ones that show up most often. Any issues before we flip to the back? So there's not going to be any work on the back. It's just going to be kind of learning a little more vocab here. All right, let's flip to the back then. And again, this sheet will be available for you to use when we get to the quiz on this. So it's just nice to have because then you've got a fully worked out example of things. So on the back is kind of explaining what some of your plots can look like. And sometimes this is the way when we're talking about data that we discuss how they look. So for instance, my first one is symmetrical. Sometimes it's also called a bell curve because basically as you start at the ends, they're weighted basically the same until you get to the middle. So there's just this kind of natural curve to them. But sometimes your data is not going to happen that way. You know, it could be anything. Like maybe a teacher does a dot plot with test scores, and the tests don't go real well. They could be skewed right. Now you're looking going, but most of this stuff is on the left. Why do they call it skewed right? Because you have very little data to this side, okay? So if I have very little data to the right, we call that skewed right. Because why is nobody getting anything to the right? That's something we have to think about. We see its opposite right below. Skewed left means there's little data to the left. So again, I'll talk about quizzes or tests. If everybody does great on a test, and everybody's getting like 80s and 90s and 100s, and barely anybody's struggling, that'd be a skewed left example of, data. Bimodal, it's up, it's down, it's up, but bi means there's two. Modal would mean there's basically two modes. There's two places where most of my people are falling. Now I know they're not exact. This would be my mode, I get that. But if there's kind of two humps in there, sort of like a camel here's back, I guess we could say, that would be more of a bimodal type thing.
So what if you get two
You can have two. Yep, you absolutely could have 2 or 3, however many there happen to be. And then the last one's uniform, which basically means you're flatlining. You've got an even distribution of everything. There's a little bit of everything going on. Okay? So this is just kind of some intro to this stuff. Now the pack that you've got with it is the actual homework. So again, keep this sheet handy somewhere because you can use it when we get to quizzes and tests and things. So when we get here, we're going to blend bar graphs in, and I assume since you've had experience with bar graphs before, I didn't do a whole lot of things with that. But one thing I will do, and I'm actually going to pause this. All right, now that we have graph paper, let's try number 1. So here's the 10 tallest mountains in the world right now. Notice, none of them are around here. Find the minimum, maximum, and range of the data. Okay. Which is the shortest mountain that we see in the chart? Okay, number 10 is. So my minimum is 26,660. Okay, what about my max? Maximum height?
29,000.
Yes, 29,035.
We mark it wrong if we don't label it. Like feet.
Yeah, I just want to know,
Number is.
yeah, the numbers, because when we go to do the graph, we're going to need those. And then how would I find my range? Yes. Take my maximum, oops, not a parenthesis. Take my maximum minus my minimum. Okay, so my range would be 2375. How far is it from the minimum to the maximum, or vice versa? So, construct a bar graph for the data set. Use the ID numbers to identify the mountains. Okay, so let's see how good I am at trying to keep all this on the screen. I'm going to try.
Does it say 2375?
Yes. So if I'm going to construct this bar graph, and it said to use the ID numbers, so let me make myself, is that going to be enough? Let's go to here. See, bar graphs, you have to feel your way out a little bit with bar graphs. Now, them telling us to use the ID numbers, that's helpful. So within each box, I'm just going to skip one here. Can I do it for everyone? Probably not. So there's 10 ID numbers. So I'll use one in each box. If you like to space out more, there's enough room on the graph paper. You could have a space in between each one, if that seems to work out better for you. Now here's my challenge though. Okay, I've got these lines going here, and I know my minimum, and I know my maximum. How much do you think it would be good for me to make each line worth? If I need to be able to cover about 2,375 feet within these lines. Well, we're probably, let's see, I've got, well, at least I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just say I've got 10 lines. Here's one way I do this sometimes if I'm not sure. You can always take your range and divide it by the number of lines that you have available. Now, you may have more lines available than me. I don't know. So it says each is worth about 237.5. I'm going to make mine worth 250. Okay. Now, if you have more room, you could do the same thing and divide. Maybe you'll have more room. I don't know. But I'm going to start down at like 26,500 because I've got to have it bigger than this number. I don't want to start at 0 and then go to like 26,000 all of a sudden. That'd be kind of crazy. So if I do each one by 250, I can just keep adding that all the way, all the way up. Now if I get tired of writing every 250, I could start skipping a little bit more. And this is one of those reasons that we look at this and go, yeah, bar graphs, not as big of a fan of. Because there's a lot more work and a lot more thinking to how this is all going to go. Because I look at these and I go, okay, so once I get here, and I'm, forming the bar part of this, I'm going to look and I'm going to go, okay, so Mountain 1, Mount Everest, a little over 29,000 feet. So I'm going to put my line in about where the top of this would be. And then I'm going to use what I have here to create a bar. Now I don't care if you leave it blank, if you color them different colors, if you make different designs, I don't care. But that's just how we're going to do this for each one. I'm just going to keep switching back and forth with black and red here. So the K2 is 28,250. And that's my ID number 2. Maybe I'll go this way this time. 28,208. That's pretty close to 28,250, just a little lower. So what I'm doing is I'm taking data that I'm looking at numerically and I'm making it more visual so I can get a visual picture of, how much taller is this mountain compared to this one. or something like that. 27,923 is almost 28,000. And this also allows me to kind of see how your estimation skills are on some things. This next one is really close, only about 100 away from the last one. So there's not going to be a whole lot of difference there. And I just keep working my way down, a little over 27.5. Then number 7 is a little below 27. What's that?
Are we going to turn this graph?
Oh yeah, because this is part of the worksheet. Yep. And then 8's barely below that last one. Let's see here. Which one am I to? Number 8. 26,760. Barely above. 26,750 is right on the line. And 26,660. Be barely up again from that. Now, to be perfectly honest, if you looked at that bar graph, would you think that the first mountain was about 3 times taller than the last one? Because you look at this little tiny bar and look at the big bar on the end and go, oh my gosh, I mean, there's got to be a whole bunch of different. And then when I tell you, well, no, it's only a couple thousand, you're like, oh. This is a way of you showing you can take data and make it look any way you want to. You can make it look really good or really bad depending on what the purpose is. So like here, if I wanted to make Everest seem like the biggest, tallest mountain there is by a long shot, this would be a good way to do it. If I wanted to show that they were closer together in size, there would be some ways for me to do that on a screen as well. So just something for you to think about a little bit, you know, as you start to work through some of these problems. And when you just start to see things in general, because media does so much with graphs and charts and things, that you want to make sure, you know, that you understand the information that's involved with it. Okay, so I'm going to move this part out of the way. And what starts to happen through the rest of these is you start to get questions based on the graphs, and you're answering them. And I believe, I'm just making sure. Okay, let's flip over for a second, because I see one that might give us a problem. Number 3 on the back of this one. Create a data set that fits the description. So let's see if we can figure this out. The median age of Shauna and her 6 siblings, is 14. The range of their ages is 12 years, and the mode is 10. So let's see. The age that shows up most often is 10. There's 12 years between the youngest and oldest. And the median age is 14, so the one in the middle. This is one we're going to have to play with a little bit. We're going to have to do a little guess and check and kind of mess around here. So that's where the calculator comes in handy, because I don't want to have to write and rewrite this a bunch of times. Who wants to do that? So let's see here. Okay, we have 7 people. So we're going to deal with 7 numbers here. All right. 12 years from youngest to oldest, 10 happens most often. How old do you think the youngest one is? Just fire a number, I don't care.
12.
If the mode's 10, I don't think the youngest would be 12.
I just threw a number out there.
What's that? 8. Okay. So let's say we had a couple of 8-year-olds. We have 7 people. The mode is 10. So if I did that, mode would happen most often. So let's say we had triplets working here. We had twins, we had triplets. Now these last two, 12 years between the youngest and the oldest. Oh, let's put a couple that are...
That's 20.
So let's see. Now would this start to fit? Let's see how this would work for me. Because I see a couple of things that might cause me a problem already. 12 years between the youngest and the oldest. Youngest was 8, oldest was 20. Okay. The mode is 10. 10 happens the most. Okay. The median. Okay, now how would I find the median of these 7 folk? Remember, I've got to go from the ends and count towards the middle. So if I go from the ends and I start counting towards the middle, what am I going to get in the middle? I'm going to get 10. Uh-oh. I don't want the median age to be 10.
It's supposed to be 14.
Crap, it's supposed to be 14. So, let's think about this again. Okay, there's 7 of them. The mode is 10. The median, okay, the number in the middle is 14. Okay, I got 3 numbers on each side.
So the youngest 2 is 10, right?
It's possible. So let's play. Let's say, I don't know, if the mode's 10, it sounds like there's 2 of them. We want to try the youngest one's 10?
What is it saying? You could.
Let's play here. Let's play a little bit younger. Let's play
2. No.
2. Oh, I don't care. We could. So the range is 12 years. I don't know, 6. Would make the oldest one 18. I don't know. 17. 16? Let's see. Mode is 10. 12 years between the youngest and the oldest. The median's 14. Okay. That works. Okay. As long as it covers what we're trying to figure out, it'll work for us. So for each of these, what I would do, 6 math tests, 8 students. I think we need to do another one of these. All right. Jorge took 6 math tests. His mean is 83, and his median is 85. But notice there's only 6 numbers. So what do I want to put in here if I want the median to be 85? I have 2 choices.
You put 86 and 87.
Close. If I want these two to average to 85, what's in the middle of 86 and 84? Okay. So those could be in the middle. Now watch this awesome trick. Means an average, right? Watch some crazy fun stuff at work. All right. So his mean mark is 83. Which means over 83 tests, over his 6 tests, he averaged 83. So let's just pretend he got 83 on every single one. So he'd have 498 points. But we already said here, these 2 in the middle, he scored 84 and he scored 86. Okay? Which means there's 328 points left for his other tests.
So you divide that by 4, right?
We could try to do something like that. Let's see what happens if we try that. Now, can I put he got 82 on every single other
You
one?
can put 82 on one of them.
Okay. I could even put 82 on 2 of them. So let's see. If I put 82 on 2 of them, there were 328 points left.
I don't think that was,
Well, let's see. I think we can make this work. And we subtract those 2 scores we just did. I got 164 points left. Can we do it that way? Because then these numbers aren't going to be big enough.
You could divide that by 2 and then like add a little bit more to the next one.
Well, here's the one thing I got to think about. Because if I divide that by 2, and see, this is the thought process. We got, crap, it's 82 again.
Yeah, no, yeah. Yeah, but you could like, oh no.
Okay, I'll just tell you the way that you can get around this. We'll keep life simple on you. That 82 number that you got, okay, since there's 4 numbers left, I'm going to add 4 to it. That'll be my 2 numbers on the end here. And then I'm also going to take that 82 and I'm going to subtract 4 going the other way. Are we going to do a lot of this type of stuff? No, but I did want to introduce you to it to try and understand how you can try to squeeze data into what you want it to be. The rest of this is finding mean, median, and mode and just reading the charts that you've got. It's not going to be anything else that you're playing with. You're going to make a dot plot for a couple of things here on the back page, and that's going to be it. Okay? So your job is to work on knocking the rest of this out. And again, you're just reading the charts, so don't make life difficult on this.